Hi, Assalamualaikum, and hi everyone. Now we will talk about Lewis structure and formal charge in Chemistry 361. And next, this is list of contents for our slider. And this is our group members, which is we have Muhammad Aiman Amin, Muhammad Aiman Hakim, Safura Alisha binti Zailan, Nailul Aisyah Humaira, and me, Muhammad Azib Shahmi.
Assalamualaikum and hi everyone. I'm gonna tell you the objective of the slide. Number 1, to explain the basic principles of Lewis structure and how they represent bonding in molecules. This topic will conduct by Azib in the next slide. Number 2, to explain the concept and rules of accurate Lewis structures. Number 3, to define formal charge and how show it is calculated for each atom in a molecule. Number 4, to apply formal charge concept to determine the most stable or preferred Lewis structure. Number 5, to enhance understanding of molecular shape, stability, and electron distribution through Lewis structures and formal charge analysis.
So now we will discuss is what is the Lewis structure actually. The Lewis structure is represent the arrangement of valence electron in atoms and molecules. The valence electron are shown as dot around the atomic symbol. The shared electrons between atoms are represented by a line which is we call it covalent bond. The unshared electron remains as dot, known as lone pair, based on the Octet rule, where most atoms are stable with 8 valence electrons. Now we will look at the example and the Lewis structure of H2O. They show the dots, we call it a lone pairs, and the line that we call it a covalent bond. So next we will look is what is formal charge actually. Formal charge is defined as the difference between the number of valence electrons in a free atom and the number of electrons remaining on the atom in a molecule after homolytic bond breaking. Formal charge, or we call it FC, is a method that we use to assign charge to an atom in a molecule. It is based on the assumption that electrons in covalent bonds are shared equally, and each atom in a bond is considered to receive one electron from the shared pair. So we can look at the formula to get a formal charge. Formal charge equals valence electron minus in bracket non-bonding electron plus with half bonding electron. So we can prove when we use to find a formal charge for carbon. So as we know, C is have a 4 valence electron, and now we get into the formula, which is 4 minus with non-bonding electron for C is 2, and the bonding electrons for C is 3, but actually they have a 6. So half of 6 we got a 3, plus with non-bonding electron that have 2, the total is 5. And now we can use to valence electron, and after we minus with valence electron we got a negative 1. So the formula is improved.
Now let's take a look about concepts of Lewis structure. A Lewis structure is a diagram. It's used to show how the atom shares or transfer electrons when forming molecules. It helps us understand how atoms are bonded together and how molecules are formed. In Lewis structure, the electron is divided into two types, which is bonding pairs and lone pairs. Bonding pairs are electrons shared between atoms and they are represented by lines. Lone pairs are electrons that are not involved in bonding and they are shown as dots around the atoms. As you can see for the examples there, there's shares between lines and dots in one molecule. Now let's take a look about basic rules for a Lewis structure. These rules are used for writing a Lewis structure. So the first rule is to count total valence electron. As you know, every atom has its own specific numbers of valence electrons based on its position in the periodic tables. All of these valence electrons are involved in bonding or exist as a lone pair. As an example, to find the total valence electron in a molecule, we add the valence electron from each atom present. Here we have the carbon dioxide, which is the carbon has 4 valence electrons and each oxygen atom has 6 valence electrons. So by then we added together, the molecules has a total of 10 valence electrons. Next, we're going for the rule 2. Rule 2 is identifying the central atom in the molecule. Usually, the central atom is the least electronegative element and is the one that can form the greatest number of bonds. This atom is placed at the center, while the other atom is arranged around it. In the easiest term, its central atom is the one that can hold other atoms around them. For example here, in a methane CH4, carbon is chosen as the central atom because it can form four stable bonds, which is hydrogen atoms. Then we're going for the rule 3. After identifying the central atom, we need to form a single bond. The central atom is connected to each surrounding atom using single lines. Each single line is represent one pair of shared electrons because of 2 atoms. In the example shows, carbon atom form 4 single bonds with 4 hydrogen atoms, creating a stable molecular structure. Now we're moving on to the rule number 4, which is an octet rule. This rule explains the atom generally prefer to have 8 electrons. This is because it wants to be stability in their valence shell. This is most common in S block and P block element, where electrons are shared, transferred, or kept as a lone pair. However, there are exceptions for this rule. The exception is not include to odd number of electrons, less than an octet, or more than 8 valence electrons. Now let's take a look about rule number 5, which is a lone pair. These rules are related with the rule number 1, which is a valence electron. This is because once all the outer atoms have full octet or full fit with the electrons, any remaining valence electron must be placed on the central atom as a lone pair. You can see on our example, there's a dot on the central atoms. However, if the central atom still doesn't have a full octet after that, we need to move on to rule number 6, which is we take lone pair from an outer atom and convert it into a double or triple bond to ensure the central atom is stable. This is a great example of the carbon dioxide where we use double bonds to complete the carbon's octet.
So before we decide which Lewis structure is the most stable, we need to understand something called formal charge. Formal charge helps us check whether electrons are distributed reasonably among atoms. So firstly, for the definition, formal charge is the difference between the number of valence electrons an atom normally has and the number of electrons assigned to its Lewis structure. It does not tell us the real charge, it just helps us compare difference between the Lewis structures. So now let's see how to calculate the formal charge. To calculate the formal charge, we use the formula Fc is equals to V minus N minus B over 2. Fc is the formal charge, V is the number of valence electrons, N is the number of lone pairs, B is the number of bonding electrons. So we divide the bonding electrons by 2 because they are shared between 2 atoms. So for example is carbon dioxide, which is CO2. So let's apply this formula to carbon dioxide with this Lewis structure where carbon atom forms double bonds with 2 oxygen atoms. First, for carbon atom has 4 valence electrons, it has no lone pairs, and it has 8 bonding electrons. So Fc is equals to 4 minus 0 minus 8 over 2, which is equals to 0. So for the both of the oxygen atoms, oxygen has 6 valence electrons, 4 lone pair electrons and 4 bonding electrons. So Fc is equal to 6 minus 4 minus 4 over 2, which is also equals to 0. All atoms in carbon dioxide have a formal charge of 0, and the net formal charge is also 0. This tells us that this Lewis structure is stable and correctly drawn. So in general, the best Lewis structure is the one where formal charges are as close to 0 as possible and negative charges are on more electronegative atoms. Now that we understand what formal charge is and how to calculate it, let's look at why it is important in real life. So firstly is soap and detergents. Soaps and detergents contain charged functional groups. Formal charge helps explain how these charges are distributed in the molecule. The charged part of the molecule is attracted to water, while the non-polar part is attracted to oil and grease. This is why soap can remove dirt easily during washing. It connects oil to water. Formal charge helps us understand how cleaning agents work. Secondly is medicines. Formal charge helps chemists design stable drug molecule and choose the correct charge. A correct charge improves solubility in blood and helps drugs bind properly to receptors in the body. This is very important in pharmaceutical research and drug development. Formal charge affects how effective a medicine is in the human body. And lastly is environmental. In the environment, many air pollutants are charged or highly reactive. Formal charge helps explain chemical reactions in the atmosphere, such as ozone formation and acid rain. It also helps scientists develop pollution control methods and protect the environment. Formal charge helps us understand and control environmental pollution. So, formal charge is not just theory, it plays an important role in cleaning products, medicines, and environmental protection. So now, this slide summarizes why Lewis structures and formal charge are important in chemistry. So for the left side on the box is the formal charge. So formal charge helps us identify the most stable Lewis structure. It is especially useful when there are multiple resonance structures because the best structure is the one with formal charges closest to 0. Formal charge also helps explain molecular properties such as reactivity and polarity. It ensures that the total charge of a molecule is conserved and helps us understand how charge is distributed within the molecule. So for example, in glycine, formal charge shows where positive and negative charges are located in the molecule. So for the right side of the box is Lewis structure. Lewis structure shows how atoms are bonded and how electrons are arranged. They help predict molecular shape using VSEPR theory. From the Lewis structure, we can determine formal charge, polarity, and resonance structures. So for example, for this diagram, which is ethylene, shows a double bond between carbon atoms which affects its shape and chemical behavior. So in summary, Lewis structures show the bonding and electron arrangement, while formal charge helps us choose the most stable and realistic structure.
In conclusion, Lewis structure and formal charge helps us to understand molecular structure and bonding. Lewis structure provides a simple representation of how valence electrons are distributed among atoms in a molecule, helping us to predict bonding patterns, lone pairs, and molecular stability. Besides that, formal charge complements Lewis structure by allowing us to evaluate the most reasonable and stable arrangement of electrons within a molecule. By comparing the formal charges, we can identify the most plausible Lewis structure that representing the molecule, which is one that minimizes the formal charges and places negative charges on more electronegative atoms. Overall, these concepts are crucial for predicting molecular stability, reactivity, and chemical behavior. These concepts form an important foundation for advanced topics in chemistry.
And this is our reference for our presentations. As you can see, there's 8 references. And that's all from us. Thank you for listening to our presentation, and I hope you guys can get what are we learning about Lewis structure and formal charts. See you again, and bye.